Oh, Mas Bondan ada 2. Loro, rangkap.
Double, Pak. Izin Bapak Ibu, kita mulai. From the speaker, Mr. Nick and Mr. Alistair, are you done with?
Good morning.
Good morning.
Good morning, but good afternoon
Afternoon.
here.
Oh, good afternoon. Apologies, good afternoon.
Okay, good morning, Mr. Alistair and Mr. Nick. I will start first. Oke, Bapak Ibu, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Om Swastiastu, Namo Buddhaya, salam kebajikan. Yang terhormat Pak Ning selaku IVP PMO, kemudian yang terhormat Bapak Ibu IVP yang hadir dalam kesempatan siang kali ini, yang terhormat Bapak GM, SRM, Manajer IVP, dan seluruh PLN di lingkungan PLNers di lingkungan Direktorat Manajemen Proyek dan IPT yang hadir pada siang kali ini. Kemudian our speaker, Mr. Nick Felix and Mr. Alistair. Good morning in your time. Sebagaimana arahan dari Bapak Direktur Manajemen Proyek dan Energi Baru Terbarukan, Bapak Wiluyo, di beberapa kali kesempatan terkait dengan excellency di bidang manajemen proyek, yang salah satunya dengan penerapan implementasi working atau ini kita berkesempatan untuk melaksanakan knowledge sharing sebagai langkah awal untuk penerapan implementasi BIM ini, di mana kami bekerja sama dengan Nippon Kui, salah satu konsultan yang ada di proyek di PLN, yaitu PLTA. Selanjutnya, sebelum kita masuk ke materi, mohon arahan dulu dari Bapak Ning selaku IVP PMO. Waktu dan tempat kami persilahkan Pak Ning.
Baik, terima kasih Mas Bondan atas waktunya. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Selamat pagi, semangat pagi, tapi selamat siang. Good afternoon, Mr. Nick Felix ya. Mr. Nick Felix as a project manager Nippon Kui, and Mr. Alistair Kell, Chief Information Officer from Nippon Kui too. Good afternoon. How are you, Mr. Felix and
Good afternoon, Mr. Felix. Thank you. Thank you.
It's nice to meet you.
Yeah. Afternoon, Mr. Henning.
Okay, may you always be healthy and happy. Thank you for your time, appreciate and willingness to participate in knowledge sharing in this time ya. Yang saya hormati Bapak Ibu IVP, Bapak GM atau yang hadir di acara ini, atau mungkin yang mewakili teman-teman dari Vice President, SRM maupun MSB dan semua peserta yang hadir di acara knowledge sharing building information modeling atau BIM yang kali ini dengan topik contact implementation and digital strategies. Ya, sekali lagi selamat siang, semoga kita semua dalam keadaan sehat, bahagia. Tadi saya pikir Pak Ganjar ini ada Pak Jeremy Farrington, saya pikir Pak Ganjar. Bapak Ibu para peserta webinar, ya, ini bisa dikatakan webinar ya, atau menulis sharing ya, nggak apa-apa, dua-duanya sama aja. Yang penting manfaatnya. Jadi kalau kita melihat dari sisi strategis PLN saat ini PLN kan telah dan sedang bertransformasi dalam 4 aspirasi yang sering kita dengar dalam sudah dicanangkan tahun 2019 lalu, dan sampai sekarang masih terus dengan segala perencanaan dan lebih mendetailkan atas transformasi yang ada yang sudah dijalankan. Antara lain adalah terkait dengan green, lean, inovatif, dan customer focus. Kalau kita ingat sesuai arahan Pak Dirut dalam berbagai media, Pak Darmon, Pak Sojo ya. Jadi proses transformasi PLN adalah menata proses bisnis dari yang istilahnya dari yang berserakan atau terfragmentasi menjadi sesuatu yang terkonsolidasi dan terintegrasi. Dari yang dulu sifatnya serba manual menjadi terdigitalisasi, sehingga memberikan dampaknya akan memberikan pelayanan terbaik bagi pelanggan PLN gitu ya. Kalau kita lihat kata kunci yang sering disampaikan beliau, dan memang kebetulan beliau juga orang IT, adalah digitalisasi atau terdigitalisasi semua bisnis proses. Jadi kita tahu bahwa terdigitalisasi menjadi roh yang sangat dimandatkan dan mewarnai seluruh aspek kegiatan bisnis PLN, dan tidak terkecuali dalam manajemen proyek, khususnya kalau yang kita ada Direktorat Manajemen Proyek dan EBT. Kita telah banyak membangun dan mendigitalisasi proses bisnis seperti PMO, aplikasi, kemudian EPIPROP, ada GPROP, ada Sidita, ada Limosin, dan masih banyak lagi dan selalu akan bertambah lagi. Dan itu juga tidak akan pernah cukup untuk terus dibangun dan dikembangkan untuk memudahkan kita dalam bekerja. Oleh karena itu sangat tepat bahwa kita yang bertanggung jawab dalam pengelolaan proyek saat ini harus menjadi ujung tombak di dalam penerapan digitalisasi di semua aspek pengelolaan proyek. Dan hari ini saya kira satu langkah kecil yang kecil tapi berdampak besar dalam rangka penerapan BIM di PLN yang akan kita jalankan ke depan. Jadi fokus kita siang ini adalah terkait dengan BIM. Mr. Nick Felix and Mr. Alistair Kell, you as a consultant for Asan 3 hydropower plant, you already know, although PLN has implemented BIM in several PLN projects, and the next one is being prepared for the Kumbi hydropower plant. Today, PLN, which is currently attended by various functions as PLN EIP as project executor, Pusmampro as supervision and quality control. There is also Pusattif here who perform in certification, and of course the Directorate of Project Management and EBT as a policy and strategic maker. Want to know and understand more deeply what is the BIM and how to apply and how to create the right BIM platform at especially in the PLN. PLN is a very big company and has many projects, and even though there is a country PMO application that has been built, it's in 2015 as a tool for monitoring, controlling, and database of all PLN projects. But as technology develop and the need for project management more advanced, then PLN need to implement BIM, starting from the process of project initiation, procurement, then project execution, up to the operation stage. So all stage and the project management. So we hope you can provide, based on your experience, of course, a complete and comprehensive description of the basic need and what state PLN need to take. So once again, thank you, Mr. Felix and Mr. Asad. Kepada Bapak Ibu hadirin sekalian, kesempatan ini saya atas nama manajemen, saya berharap acara online sharing ini dapat berjalan dengan lancar, memberikan manfaat sebesar-besarnya bagi kita semua, khususnya untuk perusahaan yang kita cintai ini. Saya kira itu dari saya. Terima kasih dan selamat mengikuti. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Aning atas pertanyaannya. Sebagaimana tadi disampaikan oleh Pak Aning, utamanya yaitu terkait dengan digitalisasi semua proses yang terkait dengan Direktorat Manajemen Proyek adalah digitalisasi di dalam proses manajemen proyek. Sebagaimana kita ketahui bahwa salah satu proyek kita yang sudah menggunakan BIM yaitu di PLTA Asahan. Walaupun memang untuk implementasi BIM-nya masih belum keseluruhan, kemarin untuk implementasi BIM dimulai dari konstruksi saja, dan kita harapannya adalah proyek-proyek di PLN bisa diimplementasikan BIM mulai dari awal, mulai dari perencanaan sampai dengan terima aset ke operasional. Mr. Alistair and Mr. Nick Felix, as we know that today PLN is in stage of setup of BIM implementation for all the project in PLN. So hopefully you can share with us. Hopefully we can get knowledge from you how to set up the BIM and also what is the advantages to use the BIM and how to set up, how to implement in every stage of the project, from the planning, construction, and also handing over to Felix from project manager of Nippon Koi, and also Mr. Alistair Kell. Mr. Alistair Kell is PDP's practice with BIM champion and regularly speaks at external events and seminars. His particular area of interest related to information management and BIM. So hopefully you can finish the presentation in less than 2 hours, Mr. Nick Felix and Mr. Alistair.
Sure, sure.
So we will spare time to for the audience to have a question, and then in the end of your presentation. So time is yours, Mr. Nick Felix and Mr. Alistair Kell.
Okay. Thank you very much. So let me just introduce myself and the Nippon Koi and the Asahan project for a little while first, before I hand over to Alistair. So as mentioned, my name is Nick Felix. I'm the project manager for the Asahan 3 hydroelectric power project in Asahan, as you may know. And we are very happy to assist the PLN in this DX transition, especially to utilize BIM on construction projects. So as you know, the Asahan 3 project is a pilot project to utilize BIM. And today, we would like to introduce my friend Alistair Kell from Nippon Koi subsidiary organization BDP. We are based in UK, in Manchester and in London. And also the BIM execution for Asahan 3 was done out of our Singapore studio. So we'd like to assist PLN to utilize BIM to improve PLN's efficiency of working and the systems within PLN itself. So as mentioned before, BDP is the daughter company of Nippon Koei, and Alistair has been instrumental in transforming the way BDP works to integrate BIM and BIM's use within the organization, and initially setting up the architecture for BIM implementation. Alistair has worked on some of the most iconic projects in the UK, and so we hope the experience he has will enable you to understand the processes and requirements for implementation of BIM within the PLN organization, and we will be happy to assist PLN through this journey. So Alistair, I would like to hand over to you now to present your presentation, and then at the end we hope to have about 20 or 30 minutes for various discussions and questions and answers. So please be prepared to ask anything at that stage. Thank you very much. Alistair, hand over to you.
Thank you, Nick. I hope everybody can hear me and can see my screen. I'm very grateful for the opportunity to present to you all today. What I've done is set out a very high-level presentation. I'd like to take you through a little bit about who BDP are and what we do. I'd like to outline the context of why BIM has been pushed forward within the UK. What are the reasons for that? And what are the benefits? I'd like to take you through some information about what BIM is or what BIM can be, and then some recommendations on how I would suggest BIM is considered to be adopted within PLN. These recommendations are based on our experience and of BIM adoption really over the last 12 years. And it is an incremental process. The other point I would make before I get started fully is that I'm discussing this in terms of architecture, engineering, design and construction. And the requirements for owner operators are part of the overall process, but are not necessarily directly equivalent to what architects and engineers do. So you'll see on the screen a very old photograph of me. My name's Alistair. I'm a qualified architect and worked in BDP for many years designing large-scale covered shopping malls. And as I moved into the role of leading our IT, BIM started to take hold in the UK. I was uniquely placed to start to drive this through. But the image on the right is of a building in Manchester. It is a university building, a mechanical, electrical, and chemical engineering building for Manchester University. BDP was the delivery architect on this, but worked with external structural engineers and MEP engineers. But you can begin to see the structural model, the services model, and the architecture model. But this building itself is about 200 meters long. The relevance of it, I feel it's important that everything I'm going to show you is a BDP project, and everything I'm going to show you are projects that we have built utilizing BIM from very early stages. So you can see this campus building opened in September of last year, and is a major part of BDP's portfolio now. So a little bit about BDP. We have about 1,300 staff as part of the Nippon Koei group. So overall, we're about 4,000 staff, and BDP has 19 offices across the globe. The majority of our staff are based in the UK, about 900. We have 250 staff in Toronto, and then offices in New York, Lima, Dublin, Rotterdam, Abu Dhabi, Shanghai, Singapore, and New Delhi. We are part of the Nippon Koei Group. We became part of the Nippon Koei Group in 2016, and we are building closer and closer links around our BIM processes and digital delivery. And you can see here the red are the BDP studios, yellow are Nippon Koei, and collectively we have an extensive network of studios and of engineering services. BDP ourselves have 17 separate architecture, design and engineering disciplines, predominantly architecture, civil and structural engineering, mechanical, electrical, engineering, public health, but we also have landscape architecture, graphic design, interior design, and everything really required for buildings. I have 3 projects that I'd like to show you around BIM that we are currently involved in or have recently completed. This is just to set the scene on the scale that we work at. The first is the AstraZeneca Global Research and Development Headquarters at Cambridge in the UK. This visualization begins to describe the research and development building itself. This was delivered utilizing BIM. The concept design was developed by a Swiss architect, but from the beginning of the process, BDP provided all of the engineering services and then architectural delivery services from the end of concept design. You can see here the building above ground, but there is a 2-level basement. This begins to show the models for the main building. But what is also interesting is in this top corner, you can see the models for the energy center, the heat pump array, which sits beneath a car park. And if I move on to the next slide, you can see this in more detail. Sustainable energy approach with the ground source heat pumps and a service tunnel linking the basement of the main building itself. So BIM, you can see here, being utilized to coordinate the external services and begin to coordinate the structural arrangements, both concrete and steel below ground and above ground. This is an image of the building during construction. I don't go into this in much more detail, but other aspects were the pre-coordinated and pre-fabricated roof system here, and you can see the building as it's been finished and handed over in spring this year. Some more interior and exterior shots, and then final picture of the main building itself. The scale of this is hard to understand from this image, but the perimeter of the main building is about 1 kilometer. So the ASEAN Hydroelectric Power Project, as Mr. Felix has mentioned, is another interesting project because it demonstrates the civil engineering aspects of BIM and what it can bring. So here we have a model of the intake weir and a construction photograph, and so you can begin to understand the scale of the project that is hard to properly realise from the model itself. But going back to the model, you can see that the concrete works, engineering works, and equipment is all beginning to be modelled. Moving on, the powerhouse and the coordination model. So you have the main model here on the bottom left, and then the large scale image shows the coordinated model with the turbines and the significant engineering equipment coordinated into the building model, which I'll talk more about in future slides. And then how this is manifesting itself during the construction process. And then one other very different project, but something that BDP is immensely proud of. At the start of the COVID-19 pandemic in the UK, BDP was a key part of a team that provided 10,000 COVID emergency intensive care beds across 6 locations, where exhibition centres were requisitioned to be used as emergency hospitals. So over 6 sites, 2 weeks for each site, we delivered a total of 10,000 beds. This here is an image of the project that was in the Excel Arena in London. But the outcome of this, it was driven by our experience in hospital design. The outcome of this was that we were very quickly able to define what was required, very quickly able to tailor solutions to different facilities. But we then set out a simple plan that anybody could follow. And this was published globally to show the necessary kit of parts and the processes to implement similar facilities. So I'll move on now and talk about why BIM. Why is BIM seen as being important? I think probably one of the most important points to get across here is that BIM is not any one thing. BIM is not necessarily a model. It is about digital transformation. It is about different ways of working to reduce waste, reduce inefficiency, and to allow more determined decisions to be made for the betterment of a facility of an organization or whatever it is defined that the target is. So to put this back into the context of what's been happening in the UK, the UK's journey began in 2011 when what is described as the level 2 BIM mandate was issued. This said that UK government would require fully collaborative 3D level 2 BIM as a minimum by 2016. So we had 5 years to implement. What it also said was that 40% of UK construction work is within the public sector, so it's government funded. And this focusing the industry on the importance of BIM adoption. In the case of BDP, what this meant was that if we could not demonstrate that we could deliver with BIM, 40% of every project would be lost to, of all projects would be lost to us. We deliver a lot of government work, and this was significant for us. So the question is why was UK government doing this? And if you take a step back from technology and from digital transformation and understand that the UK government was trying to figure out how they could deliver more for the UK society based on tax revenues, they wanted ways of spending that money better. So they believed that in looking at what digital transformation and what BIM could do, they believe that 1/3 of the total cost of ownership of an asset could be saved over the life of that asset. So if they have money to fund 3 and they deliver those 3 through BIM, they can deliver an extra asset for the same money. And this is not just around the design, the construction, but it's the whole life operational cost, being as effective and efficient as you can. Faster delivery. They believed that by adopting digital processes, the overall time spent on assessing, building business cases, justifying, and then designing and constructing assets can be reduced by 50%. So effectively, they were looking to bring services into operation within UK society more quickly. So schools would be available where they were needed, hospitals where they were needed, and they would be available sooner. Equally, by using BIM during the construction process and using it to drive off-site manufacturing, there is potential to save money because less time is spent on site, construction site. Another key aspect was about lower emissions, looking to use a digital approach to reduce greenhouse gas emissions and address climate change. And finally, improved exports, how the trade gap between the UK and other countries could be reduced, and how building BIM knowledge and exporting that knowledge could be used to introduce other services into economies outside of the UK. So construction technology, design technology, and all aspects. But as you can see, it's not about BIM. It's about running an effective, efficient economy and ensuring that money is best spent in ways that will benefit society. So what were the challenges to be overcome? Now, what I have on the screen now are the challenges that were defined by the UK. I've picked out some of the key ones, but I'm quite sure that every economy will have similar challenges, but some may be specifically tailored to local environment, local conditions. But in the UK, the rework costs during construction were being found to potentially be 20% of construction value. So being able to reduce errors during that design and construction process, have a more determined approach, will make it more efficient. It was recognised that transport and energy supply was contributing to a large part of the UK's greenhouse gas emissions, and a different approach was seen to be able to reduce that. Traffic congestion was costing the economy £31 billion, and by having a more effective and efficient traffic systems, predicting flows and addressing requirements before pressures built would support that. And disruption from flooding was costing the UK economy over £1 billion a year. So effectively, decisions that had been made around where facilities were being built, how flood prevention was being managed, needed to be more determined. But if you put this into any country, you can very quickly begin to understand what specific challenges are, so what you need to do to focus to address them. But the key part is that the built environment is becoming part of a smart, connected world, and it's data that's driving this. And as you start to move into this for the built environment, adopting BIM gives the foundations to be built upon. And the BIM process and reuse of information can and does add value to the design, construction, and operation of any built asset. So what I want to talk about now is the information and value being derived from BIM uses. And the key point here is that you will work in a consistent way to build data. But the value is actually understanding how you use that data to get value, and how you build the data to ensure that it can be used multiple times in multiple ways. And every project will be slightly different, and every organisation will be slightly different, but it's the BIM uses that matter. So a brief explanation about what BIM actually is. Well, it's a process or a workflow of creating a virtual model which describes a building or some or all of integrated information. So it will have geometry, components, and assemblies. Within that, it will have design intelligence of data added. That can be used for analysis and simulation, for manufacturing and construction, for procurement, for collaborative design, to generate schedules and specifications, to resolve design conflicts, to manage assets in operation, to ensure the safe demolition and recycling of built assets. But fundamentally, what's on the screen now, I think, is key. It's about geometry and data. And geometry is used for the coordination and visualization. And the data is what's built and attached to each of the geometric components. So in working in BIM, you do not draw the representation of a vessel. You create a virtual vessel that is placed in space and has information attached to it. And the information you attach is what's used to drive BIM uses. It can be used for design coordination. So coming back to the ASEAN project, this is a view of the power hall. And then here you can see the integration of the turbines into that space. So you can have a more determined approach. You can test and validate before you build. And you have far more confidence of the level of accuracy you're going to get. You should be constructing in a more efficient way with less need to rework. That coordination moves further. So if you have a library of components that you typically use, these are easily to hand, and you can ensure that service runs are fully coordinated, and that those that are building can understand how it should be put together with far more certainty. Equally, you can then check and verify that standard ways of methods of working are being used. This image towards the bottom shows a facility, and each one of the green boxes is fire stopping to ensure that the fire resistance of this wall is maintained. But within the UK, we are only allowed to use certified details, so they have to be of a certain size. It cannot be larger. We have a standard component library that utilizes these, and we can check in an automated way that the design complies with regulations. And that allows us to have automated checking. So here we have scripts that are run to test and validate design. And I show a little bit more about this later in the presentation. We are able to align specification with models. So large scale text specifications are written with software that links to the model itself. So we understand every component has a specification. We can check that. We have uniform references, and we automatically generate schedules with specification references between the model and the specification authoring software. So we're confident that everything is better coordinated. We're confident that the level of design is accurate for the stage of the project. And we also have greater confidence that nothing has been missed because the software tells us it's automatically. We can carry out analysis and verification of structural, of services, of environmental aspects. So here you can see the deflections on the AstraZeneca slab. moving through to the lightweight steel roof structure and how that's tied together. But visually understanding where the issues are, where the risks are, makes it easier to communicate design ideas as well. Data management becomes far more fundamental. What I have on the screen now is, first of all, an image of a single room within a hospital. BDP designs a lot of hospitals, and if you can imagine, it isn't uncommon for us to have 3,000 rooms. Now, as part of the design process, we need to capture specific information about each room. So here you can see on the right-hand side the environmental data, design data for that room, the finishes data for the room, and the activities that will take place in it. But this all comes from a database and automatically populates drawings and provides information that's easy to be accessed by every designer through the procurement process and the construction process for what these requirements are, rather than unlinked, separate, unverified paper. What then happens is that within every room, we position every piece of medical equipment to ensure that it's properly coordinated for services, for structure, and the activity zones around about it all work. So on the right of the drawing, you can see the equipment list. So every piece of equipment in that room, and the quantities and the references. Now, all of this comes from a database. So all of a sudden, whilst we have the information for every piece of equipment in any one room, we can turn that round and we can confirm every room that any single piece of equipment is in. Now, we will attach the maintenance periods, the replacement periods to this. So very quickly, work schedules can begin to be brought up for the maintenance within that hospital. And the same principles apply to any built asset. Come back to the ASEAN Power Hall. The same could apply to specific pumps, circuit boards, turbines themselves, with automatic triggers defining when maintenance is required, or automatic monitoring, confirming when the equipment is beginning to move out of tolerance. So the predictive maintenance can occur. We use computational design. And if I move on to the next slide, it's just a very little short video that shows how computational design can be used to drive structural design or repeatable built forms. This is a stadium that our one of BDP's companies, BDP Pattern, designed and built for the Qatar World Cup last year. But you can see as parameters change, the design is understood and is optimized around typical bays and around the curves, and this moves all the way down into the design of the concrete bolts, the seating plans and viewing angles. But using this automated approach allows us to be more determined with the way that we design. Offsite manufacturing is something that we are beginning to see real benefit from in the UK. So using the model geometry, we export specific requirements and pass them to specialist subcontractors that will carry out manufacturing offsite. This gives us a number of benefits. So the quality of the product from a factory typically is better than built on site. The health and safety aspects can be better controlled, but the site logistics themselves are improved, and the project program is condensed because activities start to run in parallel rather than sequentially. So what you can see here is the wall paneling, and here we have that arriving to the site just in time. So the day before it's required to be installed. In this way, projects can be progressed in a far more efficient manner. What you're seeing here is the Alderhay Children's Hospital in Liverpool that was delivered, I think, 7 or 8 months ahead of the original programme because of the adoption of BIM, because of, in part, through this offsite manufacturing process. And then visualization and communication. Again, coming back to the ASEAN Power Hall, the ability to generate visualization for simple design communication as an outcome of working in BIM, rather than visualizations being a separate activity, can really drive decision making and communication very easily. But it can then move to support virtual reality. So if everybody on the call has a mobile phone and scans one of the QR codes in the bottom right hand side of the screen, you'll be able to bring up the virtual reality image of the power hall. Very simple, but it democratizes the ability to share information in quite a powerful way. We certainly found these aspects of BIM some of the easiest gains, but some of the most valuable gains for those that we collaborate with and for our clients. And then this just takes things a little bit further, where we are able to present websites to clients that will allow them to navigate around their the facilities that are being designed. They can use these for ongoing stakeholder communication, but it allows them to best understand what's being created for them. I won't go into this now. Just move on. And one of the other outcomes, and this starts to talk about the design management of project management. We build bespoke tools that allow us to monitor design progress or monitor construction progress based on the way that models are being developed, the way that the information is being built. So here you can see simple dashboards. These are all developed by BDP that we run models through to understand how work is progressing. You can see, if you look at this middle section here, the Kobe check, everything in green shows the parameters we expect to be built at a particular point in time. We can see the amber sections are the ones that are missing. We can go in and target that work, make sure the team is getting it right. We also look at model warnings and understanding errors that may exist in the model that need to be addressed. And then asset management. I said at the very start, BIM adopted early on in a project sets the foundations for digital transformation, and it sets the rules for models to be developed that get passed through design, procurement, construction, and then ultimately asset management. And what you see here is this is about space utilization, but the model itself can be imported into asset management software, and then this is used by the end user client or facilities managers to support ongoing work. And you define the uses. So as there will be BIM uses for the design and construction, there are BIM uses and technology uses that can take advantage of this information for asset management. Now, the ultimate aim is to support a digital twin approach. The term digital twin is something that has grown in prominence over the last 4 or 5 years. But simplistically, the intention is that you initially define a set of requirements. and the design team reviews and develops multiple options that are then assessed and evaluated. Simulations are run, and from those simulations, the designs are improved. And you would run round and round this loop until you reach the optimal solution. That then moves into the delivery phase, where the asset itself will be built, and you will have a virtual version of the digital twin. Within that, we would expect that there would be multiple sensors and monitoring devices, all linked back to a virtual twin that is constantly measuring the physical asset in its operation. And that data is captured and is used to optimize the physical twin. So is running through that asset management piece. But then when there is a requirement for an additional asset, this information has been gathered, has been held, has been assessed, and is used to better define requirements for the next. So you then run around the virtual cycle again. Equally, that you can use the data to better simulate and evaluate in the virtual world what options there may be to optimize the physical. And you end up with this infinity loop of ever improving opportunities to ensure that the physical assets are optimized and tailored to the specific requirements at any point in time. And that's where BIM is ultimately, what BIM is ultimately trying to drive and trying to support. So I'm now going to move on to talk a little bit about business strategy. There are many standards and multiple terms. I'm going to try to avoid a lot of them and talk slightly higher level to set the scene and set the philosophy around what we are seeing in the UK and what we believe any organisation can do to help adopt them. So I'm going to talk about strategy, and then I'm going to move right down to the simple steps that can be made to get on the journey, to get on the path. So I put together this diagram, which starts at the bottom and says that any organisation is setting out to create or acquire new assets. And this is about the delivery of capital new build and refurbishment projects. Now, for any organisation, you need to define the outcomes that you require from your digital transformation, but specifically the outcomes you require from any capital delivery project. And what I've suggested here is that for any organisation, you would expect capital projects to be delivered on time, to be delivered on budget, and to be delivered with zero harm. Now, that could be harm to the environment, it could be harm to workers, it could be harm to the community in which that asset sits. But it's defining a target that you want to try to achieve from BIM adoption. Now, the step above that is that you have that asset delivered now, and you want to look at how it's operating day to day. And obviously, you would look for that infrastructure asset to be performing optimally and to be of high availability for that individual asset. So, the outcome here is that you're attempting to have that high availability of all assets. The next step is about a managed portfolio of assets. So you want the network to be as effective and efficient as possible. And then at an organizational level, it's about future sustainability. Sustainability of the organization, but ultimately it's sustainability of society. So you have these increasing sets of business activity, but strategy feeds down to each. And in terms of a delivery model, the terms that start to come into play are BIM and digital delivery of a capital asset, a smart asset or a digital twin for day-to-day operation of any single asset, connected smart assets, digital twins for portfolio management, but the ultimate corporate aim stays the same. But the challenge is that for any organization, each step brings increasing complexity and increasing organizational change and organizational competence. So the message from this is set a strategy, but start small. And there are standards and processes which can be adopted to help achieve this. So within the UK, we've been through many different stages, but we now have a published BIM framework with BIM standards that are now internationally recognised standards. But these go through four areas. The first is about design, so standards to be adopted during the design stage. They then move across for the building stage. Additional standards adopted during the operational phase, but they're all fed from these early stages. And then a final set that's around the integration of information across multiple assets. The way that these work and some of the key aspects come back to this diagram that is included in all of these standards, where the organizational requirements have to be defined. These then define a set of asset information requirements. So both of these stages are client defined. They both contribute to exchange information requirements and project requirements, which then feed to a project team to initially develop a project information model. And then they contribute to a client asset information model. And this is where these different stages fit. So within delivery, design and build, exchange information requirements feeds project model. The asset information requirements would feed exchange information requirements, which feeds the project model, and which then feeds the asset information model. And then organizational requirements feeds down, around, back up again. The point here actually is you deal with it in simple stages, because if you try to achieve the whole thing in one go, it becomes so complex that you never find the right time. And within the UK, when BIM started to be adopted, it was at this level where exchange information requirements were provided by clients to project teams at the very start, that defined the way they were expected to adopt BIM, to utilize a project information model. In reality, that was the best we saw. And typically, what we actually saw was no client requirements really being defined, an aspiration to use BIM, and designers and engineers adopting BIM because they knew that they would produce a better product. They would reduce risk through the information that they produced. But without client requirements, there was no ongoing benefit brought. Design coordination was better. The errors within information were reduced. Visualization was delivered, but it was all design team best endeavors. The step above, as I say, asset information requirements are understood, feeds down, feeds across, and then there is a delivery aspect from the design team, and that asset information is used to run day-to-day operations, and you see in complexity increasing. And then the final step, organizational requirements, down, round, and back up, and this is where real benefit starts to be achieved. So there are standards there that support structured, referenceable, accessible data, and using appropriate management systems, we all improve. But there are specific elements of BIM delivery that I think are worthwhile just touching on a little bit further, that PLM can understand. And we use this diagram. So what's on the screen now are the components of typical BIM, the typical management of BIM projects. There are client aspects to this, and there are design and engineering team, project management team aspects of this. But it starts with appointments. Within any appointment, there should be scopes of service that reference BIM. We would typically look to see information exchange requirements and something called a BIM protocol, which defines ways of working contractually between different parties. We would expect to see a program and a plan of work, logical progression, and beginning to define what the activities will be within each primary project project stage. And the exchange information requirements, moving into the digital delivery aspects. And they feed into additional client design and briefing requirements. The outputs we would expect are a BIM execution plan. Within that plan, processes, BIM uses, standards, methods, and procedures will all be documented. And these flow into the project delivery process managed by, in this case, BDP's design team leader. And they run round during each project stage with 3 typical outputs. Now, we'd identified here the visual character, the design or the engineering, how the brief has been achieved, the geometric definition, how it fits together geometrically, and then the data definition, the information attached to geometry, and then the ability to check. So it's about robust model and data deliverables. And feeding this through, within the UK, there are standard suites of appointment documents now, very similar to the FIDIC documents that are used within your region. But the CIC is a UK Construction Industry Council. There is then a standard plan of work, a standard set of project program stages and activities that was developed by the RIBA. These are stages 0 to 7. And these will become important in a couple of slides' time. But if you remember 0 to 7, starting with inception and business case, moving all the way through to handover and assessment and use. There's then the employer's information requirements, the required deliverables, the information deliverables, data deliverables. The brief and design requirements, project delivery, standards, methods and procedures, design quality, model geometry, model information, and then checking and verification of that information, ensuring what has been asked for is being delivered, and the detail down to individual parameters is accurate. Now, as I said before, at the start of BIM adoption in the UK, we had many projects where there was no client requirement, or at times a client requirement was introduced after our appointment. So we developed this diagram that simply talked through with our project teams and with our clients what to do at different stages. So what stage is the project? 0 to 2, early stage, 3 to 6, late stage. Are there exchange information requirements? Yes or no? Follow that through what the responses are. And we developed this typical approach. So we were supporting client adoption, client understanding, with standards and information. The first point is common data environment. Every project should have a common data environment and document management processes in place to ensure that there's accurate project information available to everybody. Everybody has the same revision and is using the same level of information and can trust what they're given. So there are standard workflows. What this diagram describes is work in progress through an approval process is then shared for design coordination, authorised to be published for procurement or construction, and then as information is revised and updated, there's an archiving process. But common data environment, absolutely key to any BIM implementation. Execution planning. We have standard documents that define those standards, methods, and procedures that we adopt. And what we then began to do is ensure that those documents are tailored to a client exchange information requirements document. And what you can see on the right-hand side here is that within any BIM execution plan, we will go through every clause within our brief, define whether we're compliant with it or not, and then respond briefly to identify what we are doing to comply. So here you can see exchange information, the execution plan, then sitting behind that design responsibility matrix, which I'll come on to, and the modeling protocol. Here you can begin to see how we build up this design responsibility matrix. Now, what we do is define every element within a built asset, and we look at every work stage. So this is the RIBA plan of work, but this talks about the logical project progression from definition through construction, handover, and in use. And then define at each stage who's holding primary responsibility, the level of information that's needed at that work stage. So LOD 2, LOI 2 corresponds to work stage 2, and then who contributes to it. So there's clear definition and understanding of responsibility. What we also do is begin to define the classification, the coding structure that will be adopted. And it's this structure that starts to get built into the data around any model component. But everything is made clear, but because it's clear, it's also auditable. So it reduces conflict between design members as everybody understands what's necessary. So here you can see ceiling and soffit systems, what the primary code is, who's responsible for what and when. And you can see the responsibility changes from architect to specialist and main contractor as we move into construction. But data classification is important. And I've used this example because we're talking about a toilet facility. But depending on the region you work in, that can mean a different thing. I'm here talking to you in English, but knowing that English is not your first language. So there needs to be a more determined means of communicating. And this is where data classification comes in. And what the UK then standard tries to do is to have a uniform classification that's used not just across a project, but across all projects. So it is almost like a barcode on a product that can be in any store. Having that ability to have that consistent coding suddenly brings much more accessibility to information. So here you can see New Zealand, Spain, Japan, and Indonesia. The code's the same. The language is different, but the code is a piece that's understood. And then model development is worthwhile understanding as well. So here you can see we're at work stage 3, and this is the typical of the complexity that we would model at work stage 3. It is three-dimensional. It is coming from BIM, but it's relatively simplistic because that's what's needed to develop the design. You move forward into technical design stage, you begin to understand the complexity has to increase. The definition has to be stronger because you're moving to be fixed and to move into the construction stage. The next image then moves this from the designer to the specialist subcontractor who's producing manufacturing and installation drawings for the same thing based on information passed to them. So they aren't starting the process from the beginning. And then through to construction and installation on site. But that just shows the logical steps, the increase in detail and the equivalent increase in information that will be sitting behind all of this. And this information is the really important part. So what I have on the right, I showed at the beginning to discuss geometry and data attached. Well, what's on the left-hand side now is our typical asset management requirement that we would bring to any client that didn't have this. And it shows typically the data that we would look to capture during the later stages of projects. So you can see here, this information exchange number, you've got number 3, number 5. These are the project points where we would look to capture this information. So everything that is 5 is capturing procured and installed information about every asset that's from the contractor. So that this is then all passed over at handover to be used in facilities management, asset management. But this typically will be done for every unique component that has a serviceable requirement.
Hey, kung ngerti ka, Raska?
Hey, is that a question?
No, I think.
Right. Okay, now I'm very close to the end. So what I wanted to do was, I think I have 4 or 5 more slides, was to talk briefly on the BIM adoption and the phases that we saw within the UK, because this points to what I've seen happening on the Asset and Power project and what I understand the intent is within PLN. So simplistically, the design stage, we saw in the UK that architects and engineers adopted BIM because they could help better coordinate and reduce risk on projects. And initially, they did this without client requirements. And it was managed by the design team. It required every member of the design team to be at an equivalent stage or have an equivalent desire, but it happened organically. We then saw that during construction, contractors saw the benefit, ensuring that there wasn't reworking, that coordination issues were addressed before work happened on site. But what we did find though was that different contractors had different levels of competency. So we tried to determine the competency of contractors as they were bidding for work. We saw the operational phase as being challenging. And actually, we still see the operational phase as challenging because you need early definition. You need to understand what the aim is for the end to be able to properly define briefing. And this comes back to organizational requirements, asset information requirements, and exchange information requirements. So that typically the operation informs the briefing. And once that brief is there, it informs the design, which informs the construction, which leads into operation. So the message here is you can start in a limited way, but define and build from that position, because if you stay just with that limited position, you get limited benefit, which is what this is about. So in the initial stages, in the first projects that we did with BIM, there was no contractual requirement. It was about benefits being limited to the best endeavours of the team. There were no real implications on the way teams were set up and were organised, but it was low risk. That then began to develop into design benefits, where clients were looking to seek design teams that would work within BIM. They would seek some deliverables, but these were usually quite limited. So design coordination definitely would be there, analysis, visualization, and at times providing models for procurement. But again, it was defined within design team appointments. The organisation and management of it was still delegated to the design team themselves, and it's still limited risk, but clear deliverables were necessary. Moving that into on-site benefits, it takes it a step further forward. And the problem is within the organisational aspects, those that are managing the project need a greater understanding of terminology, of what the benefits of BIM are, and how to expect that to manifest itself in the way projects will typically be set up and run, because it does change. There's increasing risk, but there are clear deliverables and increasing benefits. And then that moves into the operational phase, which, if I am honest, the UK is still attempting to get real value out of. But every year we get closer. So it's about a full BIM adoption through design team, contractor, facilities management, and operation. And all aspects, all valuable BIM uses, project by project, are adopted. A client BIM manager, information manager will be required. Greatest risk, but structure, resources, and definition is key. So, what can hamper progress? This next slide, I think, is really interesting because it demonstrates the problem that the UK still has, but it shows what not to do. So there was research carried out by a university that assessed all of the typical websites that were used for research and for information by the construction industry. And you can see here contracts and payments, appointment, client procedures, sustainability, health and safety, etc., etc. These were all the topics that were searched for by individuals, and you can see how they link together, and they all link together. But then sitting out on its own was BIM. And what this suggested was that BIM was being promoted by a small group. And actually, the real value is when BIM is sitting in the heart of all of this as well. So it's imperative that the philosophies and the structures in the organization around about BIM are properly understood and properly embraced by all parts of an organization. You will need specialists, but the specialists need to be included and inclusive in themselves, because without it, you won't get the full benefit. You will get benefit, but it won't be as good as it can be. So, final few slides, and then we will have time for questions. A standard structured approach is absolutely key. Measured and having ambition, but don't be too ambitious too quickly. So what you see here is the roadmap that our engineering profession adopted in 2012 to define the benefits they were going to bring to their profession by utilising BIM. And they looked at projects, and they looked at new software to be adopted, they looked at new processes to be adopted, and they looked at the way that they could train their teams year on year. So this goes all the way back to recruitment and staff retention and staff development, and seeing where the greatest benefit could be to the profession, and continually, setting out for 3 years, trying to achieve a target, and then setting another 3-year plan. And what we found was, when we started on our journey, very quickly, every 6 weeks, we almost found something new and valuable to bring to the business, and we did. But the further down the journey you get, the more complex things become, and the harder it is to achieve these benefits. But set out a clear plan, try to define what is achievable, bring the benefit, and move on to the next the next target. And whilst every organization will have their different uses, every organization will require different software potentially, different information to drive those uses. This is typical of the software stack that BDP and Nippon Koei will use as part of adoption. So sitting in the heart of this, we use Autodesk Revit. We use it for geometry and for some data capture. To the left, we have a significant number of existing models, and we take components from those models. We run them through a process which unifies data. So we give every project a defined starting position with data, and we deliver that through a platform called Kinship. It's a component library. We have MBS for our detailed text specifications, but that separate database links into Revit. So there will be standard references that link the two. And we use an additional product called Dorophus for multiple data that wouldn't sit within Revit or MBS, that again can be used to be reflected in drawings or as a separate database, and again linking through. So component references, room references, that's what holds all of this together. For our early stage design, we have a range of products that assist with generative design, scripting and coding. So Grasshopper, Rhino, and Dynamo all assist in defining geometry, making sure it's correct. We then use products for visualization, like Enscape. The QR code that I showed you is from Enscape. We use Navisworks for geometry coordination at a real technical level, Revisto for information management. And then these products here are typical of what Nippon Koei will use. So Costex for costing, Primavera for programming, and Synchro is a useful product for preparing visualizations for construction sequencing. All of this information is passed through our standard auditing process, and then it's published into Aconex as a common data environment. And this is typical of the technology stack that we have. Each project will flex slightly, but you can see that it's quite an undertaking. And this is really us coming to the end now. What's on the screen is the new Children's Hospital in Dublin. It's the largest construction project currently underway in Ireland that BDP has delivered from its inception in 2014, using BIM methodologies. Everything that I've showed you today is adopted on this project, and it is, I believe, being handed over next year to be put into operation. So with that, I'm at an end, and I'm happy to take any questions anybody might have.
Thank you. Hello.
Hello.
Thank you very much, Mr. So I'm really sorry I have to switch off my camera because some internet connection is really good. So from the audience, somebody want to have a question? Please directly express to Mr. Alistair.
Mr. Alistair, I'm Rati from BLN Engineering.
Hello.
Yeah, the BIM is ideally for ideal situation. The BIM were implemented since pre-project or pre-construction, right?
Yes.
Yeah, but how about there is a mostly project in PLNs were already on progress. Not every project in a contract phase or pre-construction phase, but mostly a project in a PLN in progress, like 20%, 50%, such as how is BIM implemented in the kind of situations?
I think it depends very much on the stage the project is at and the potential benefit it could bring. You know, my advice would be not every project will be the same, and the right decision may actually be not to implement them, depending on where the project is. But I would expect, for example, every project to be using a common data environment. Every project to have standard document naming, standard revision history, and standard information use coding, which is all part of the BIM process. But it is not necessarily adopting model geometry. And with that, you begin to reduce risk. You begin to introduce some of the language and some of the processes that are within the BIM standards. So you are beginning to upskill without fundamentally changing the way that the project has progressed, and potentially introducing the risk of additional cost by trying to move a project from being 2D to being 3D and BIM too late in the process. We work on projects where during concept design, during early stage design, we will work in 2D, or a project will be given to us in 2D, and we will build it in BIM. Towards the end of a concept feasibility stage, because we know that we can provide benefit to our client. But if, for example,
Alistair, can I add something?
Yeah.
Interrupt, yeah. So there's different stages, as Alistair was saying. So even if we haven't identified BIM during the pre-feasibility or feasibility stage, we can still try to implement aspects of BIM at the stage of procurement, or to identify items which we need to put into the construction documents, on contract documents. And where there are projects that are actually currently operating, that is possibly the most difficult stage to introduce BIM, where you're actually starting to execute the works. In the terms of Asahan 3, we tried to do it by implementing variation orders to draw BIM into the design process. But that really depends on the capability of the contractors that we have in place. So, for example, at Asahan 3, the M&E contractor to providing for the generators was not very at a stage to do BIM, and that made it more difficult. Whereas the mechanical engineering contractor was at a very high level stage of BIM, and we could introduce it halfway through the works during his design. So it really depends, as Alistair said, on the project and what benefits you're trying to get at the end from implementing BIM. Hope that's answering some of the question. Somebody else is asking? But was that okay? Or you want to follow up?
Ibu dari PLN, mohon maaf.
Yes, I think
Yeah.
so it's mean if we implemented BIM like in Asahan in the middle of the projects, the BIM will follow the designs that already approved, right?
Yes.
Just
yes,
in case they find BIM find, or the BIM engineer developers finds the class or class in the class detection and extra, it's gonna follow the designs, not the opposites, right? That am I
Yeah.
right? Sorry.
But basically, yes. The design was already there, but there was a lot of integration needed because Asahan had 3-4 different contractors. So BIM was mostly used for the federating the final model.
Okay, one more. In a phase of implementation, which phase need a longer time than other phase, are in the 3D, 4D, 5D, or like asset information model or physical models, or etc. Except the permit or approval, because it's common issue.
Alistair, maybe you can respond to that. Which phase takes the longest to implement? The design phase, the execution phase, or the AIM phase?
I think what we see in the UK is that the asset phase is currently the most challenging. But that may simply be because the design phase and the construction phase have been doing this for longer and delivering the benefit for longer. It comes back to the diagram I showed, where to get the asset phase properly defined and properly correct, you need to feed that into the briefing process at the start of the design, or certainly within construction procurement documents. And typically, we found that client organizations recognized that there was benefit from BIM, but found it harder to organize themselves to define that briefing.
Talking about that with respect to PLN, for example, PLN, I believe, have a lot of assets that need O&M assigned to them. But sometimes within depending on the funding authority, etc., we cannot specify exactly that particular type of tool or equipment to be installed because it goes against the procurement rules. So, but I think that is one of the difficulties that may occur within PLN as an organization later on as we go through the procurement phase. Yeah.
Well, my advice, which may be very theoretical, it comes back to the organizational requirements. I would recommend that for any group of assets, and I don't understand how PLM's organized, but I would suspect that there will be regionally groups of assets, or there will be operating units that deal with particular types of asset. So at an operating unit level or at a regional level, you would look to specify and implement the tools that you would look to use to typically manage O&M material for each asset. Then what that leads into is that as part of the procurement process for any individual asset, you specify the tools that you have in place, the tools that you will be using, and the information requirements you require any project to deliver to be loaded into those tools. So you're not specifying and procuring the asset management software itself because you've done that at an organization. You're specifying what you need to drive it to make it work, to make it more efficient.
Yeah, the procurement issue is always going to be a difficulty relating to the procurement rules of various organizations within PLN and outside of PLN, depending on how the project is funded. So yeah, I suspect that going back to your question, the procurement phase is going to be the most difficult to define what PLN want and how they want to implement it at the end, really.
Mm-hmm.
Okay.
Okay.
Once more, Mr. Nick and Mr. Sayers, regarding about the presentation slides when you show about software, if retrofit Autodesk is really powerful, then why we need still Primavera and Synchro applications in a 4 or 5 stage? I think it's already in Autodesk Revit. Am I right?
The tools that we use, we believe are the best available. And what we do find is that some of the Autodesk tools are market leading, and others are not as good. So Primavera, Synchro, Costex, we believe these are better tools than the Autodesk equivalents. What we also find is that architects and engineers typically went from AutoCAD to use Revit, but cost consultant project managers typically never used Autodesk tools in the same way, used Primavera, used Costex or other equivalent products from separate suppliers. And are more confident in using those tools. So this is a very interesting question, and it's something that I ask my teams internally as well. But if you try to use the best tool for the job, it's not always an Autodesk tool, unfortunately.
Yang sudah cukup? Is it enough?
Okay, thank you. Thank you very much, Mr. Alex, Mr. Nix.
Okay, thank you very much. Ibu Rati. From the audience, want to have a question?
Yeah. Thank you, Pak Bondan, Mr. Kel, for the opportunity. Honestly, it's a new thing especially for me, about BIM. And what I want to ask is maybe about a little bit technical.
Yeah.
First of all, about the software, how about the compatibility across software? I mean, between software that you use and the others. Is it easily vice versa, or? And then wait, maybe I'll just continue to my next question.
Okay.
Sorry. Yeah. In case of I want to build, let's say, a power plant, and I only have such a small amount of space available. Using this BIM, should we manually draft the layout, or the BIM can do it itself? And then the last question is, what if we have wide variation of the designs? I mean, or should we have only one fixed design to be implemented in BIM, or how? Yeah, maybe that's all.
Okay, well, I'll start with the first question. Yeah. Interoperability between software is always a problem, always a challenge. In part, this touches on the earlier question about Autodesk software. The compatibility between Autodesk software should be seamless. It never is. But you have a better chance of achieving it there. There is an interoperability standard that uses something called IFC, but the production of IFC introduces more work into the process, and IFC in itself tends not to be as data rich as staying within the Autodesk stack. So yes, interoperability is a problem, but with Autodesk being the predominant software package for architects and engineers, it tends to offer better opportunities than others. And the Autodesk tools themselves will bring in their Civil 3D product, will bring in all of the different flavors of Revit, and will allow integration with their Navisworks platform for coordination and their BIM 360 platform. So yeah, it is always a challenge. The second point, from what I understood, you were discussing was whether or not you would develop design options in 2D and then take one of those options into BIM. I think we have done it both ways, where we have worked up design options in sketching, in drawing, sometimes even producing CAD to test, and then we'll pass one option into BIM. So we have done that. I think the more confident people get with the process, and the more confident people get with the software, I would expect them to design and test multiple options in BIM in a simplistic way, and then take one or two of those options forward within BIM. So by starting the process earlier, you keep the benefit, and you aren't having to completely start again at some point and put aside all of the CAD work that you may have done. And so your third question.
Yeah, in case we have a very small amount of space available, that should the BIM arrange the layout automatically or something like that?
I think that at the moment the automatic layout testing, I'd suggest if you go to research the Autodesk generative design options, there are ways within the process where you can have the system generate multiple different options for you to assess, for you to define criteria, and it will optimize. And this is possible, but you will require a level of understanding and probably need some more highly trained people to be able to get those benefits.
Okay, I think it's enough. Thank you, Mr. Kel.
Thank you.
Okay, thank you, Mr. Alistair and Mr. Nidi. So the next question, I think, from Mr. Dimas from MGG. Mr. Dimas.
Oke, makasih Mas Bondan. Good afternoon, Mr. Kel.
Afternoon.
Okay, you're saying about twin digital technology. I think it is really important not only to visualize the object or to digitize the objects, but also I think it helps us from planning stage to commercial operation develop until operation maintenance. And once it's applied, I think twin digital it should support our asset management. The question is that do you have any success story, maybe in like UK or like in any European Paris Treaty, which that has BIM or building information model as used as twin digital. So I think it can be like give us like benchmark for us.
There are an increasing number of buildings now that are beginning to demonstrate benefit. I think the challenge is that it is still developing, but certainly in hospital design and hospital operation now, there are standard platforms that the UK government is requiring hospital projects that they fund to use that allow, at a simple level, better management of the availability of beds, better management of the energy consumption in a hospital, better control of the logistics of even cleaning, operation, and maintenance. So yeah, there is. I can look to find some case studies and pass them through Mr. Felix for distribution.
Okay. But, yes, thank you. But I think just suggestion maybe if like I don't know if like right now because in Pasangan use BIM, maybe it is possible to make it like use case or pilot projects. So next we can consider to use BIM as a twin digital.
Oh yes, yeah. I mean I can speak to Mr. Felix after this meeting about opportunities for exactly that. I think that case
Can
studies
I just
will
jump
show
in a little bit, Alistair?
Yeah.
Sorry. So Dimas, I think for the hydropower schemes, digital twins are maybe a little bit difficult. But maybe for the substations, switch yards, etc., maybe digital twins are more simpler to do. But for the for gas-fired and steam-fired power plants, etc., maybe digital twinning can be more easily done because there are packages of and elements similar to what Alistair was talking about in terms of the beds, etc., that can be moved around. So you have standard circuit breakers, you have standard elements that go inside a switchyard or something, and substation. So, but for the hydropower scheme to utilize Asahan 3 as a digital twin may be difficult, more difficult, because it's so dependent on the geology and the location. Yeah.
Is it included with the substation? Maybe if like the BIM is used in substation,
yeah.
the core station should be.
Yeah. So if it is utilized for the substation, in Asahan 3, our pilot scheme didn't do too much on the substation and the switchyard, but if we extend it to that in the switchyard, then the digital twin aspect can be probably drawn out better. Yeah.
Okay, thank you, Felix.
Okay, thank you, Mr. Felix, Mr. Kel, and Mr. Dimas. I think because of the limit of time, one more question from Mbak Arum. Am I not wrong?
Okay, thank you, Mr. Bondan. Good afternoon, Mr. Alistair and Mr. Felix.
Okay.
I'm Arum from UPP GBT 1. I want to ask question relating to the connection BIM and the project management body of knowledge. Yeah, from your explanation in the start of the presentation, it is explained that BIM integrated several information such as from the design and then procurement and schedule and so on. So meanwhile, in the project management body of knowledge consists of several knowledge areas and process group from the initiating until monitoring and closing. So how far BIM accommodate the knowledge areas and process group in project management body of knowledge? From my view, that BIM is maybe more than that, yeah, because it is include the asset management and then demolition and so on. So, but if BIM cannot accommodate all of the project management body of knowledge, how we can implement BIM, but maybe we can combine with another system, so we can ensure that we implemented BIM based on the process group and knowledge areas from body of knowledge.
I think if you consider the different processes that you do, and if you consider them as within BIM, I would describe them as BIM uses. So each activity will be a separate BIM use of BIM. Now that may be quite different between a project manager and a facilities manager and an architect and a contractor. But what ties it all together is that there's a common set of processes, a common language, common data classification that if you consider this more as digital transformation, the BIM uses are the things that drive digital transformation within any area. And within architecture and engineering, it is called BIM. But in reality, it is about having an approach to data and the way that you use that to be more effective, to be more efficient, to be more accurate that matters. One of the ways of describing this, and I'm going to move out of construction, and I'm going to talk about a supermarket. So if you can imagine now, you go into a supermarket, everything has a barcode. You go to the checkout, the barcodes all get scanned, it's all automatic, and then at times in the UK you have a loyalty card, so you scan your loyalty card, and you pay your bill. But what's actually happening is there is a digital approach that has made that far more efficient than what would have happened 20 years ago, where every single item would need to be entered manually. Every single item would need to have a price put on it. And there would be no record of what I had bought as a customer. But the digital approach makes that far more efficient. And the construction industry is far behind many other industries in adopting a digital approach. And what BIM is beginning to do is to change that mindset, is to look at the power of data and where that can make us more effective, more efficient, reduce risk, limit unnecessary cost. And to your first question, there is opportunities, but you need to understand where if you were to change one process, what is going to give you the best benefit? Select that as the first process. Understand what the opportunities are to change it, where the data needs to come from to change it, what the outcomes you can then get, and the opportunity will be there.
Okay.
So does that make sense? I feel I've probably been overly complicated, but if you think BIM use, forget the word BIM and think data use. What data do I need to change my process, and what benefit will I get from changing that process? And then where's the data coming from, and make sure that those that are provided to you do it accurately.
Okay, Barum, is it clear? Is it clear for you?
I think quite clear. Thank you, Mr. Esther. Thank you, Mr. Bondan.
Okay, thank you very much. I think the time is over, but I still have one question in the chat, but I think this question will be answered in writing because the time is over. So once again, thank you very much, Mr. Kel and Mr. Felix, what an interesting discussion today. I think this is still a lot of big question mark for PLN because this is still new for us, and still a lot of things to do, how to implement BIM in PLN. But one is BIM is the different way of working. So this is new. This is new for PLN.
I think it's exciting times. I think it's important to recognize the commitment and the PLN is making, and the understanding that this is the right way forward is absolutely right, absolutely valid. It's not going to be easy, but nothing that brings you benefit will be easy. So, take simple steps, demonstrate benefit at every step, and the very fact that we're having this discussion, I think is very positive. Should be commended.
Yeah. Okay. For the audience, I think this is still the early phase of how we want to implement BIM in PLN, but there is still a lot of programs that we have to do. So the next things we have study funding in another company that we have already implement BIM, so we have more clear point of view how we actually implement BIM in PLN. So thank you once again. Thank you very much, Mr. Alistair and Mr. Kel, Mr. Nick Felix. Hopefully this will give us knowledge a little time how to implement BIM in PLN. But for the closing statement, maybe from Mr. Nick, want to closing statement?
Okay, thank you very much. So as Alistair said, what I want to close with is really, it's an exciting time, and PLN I'm happy to see, I've worked with PLN for 20 years, and I'm happy to see that PLN are embarking on this new strategy, a new way of working. And I think it's a benefit for PLN as a whole to be more efficient, to centralize their planning and their way of working so that each new project is not completely new, and to become more efficient in producing their operation maintenance systems and their design and procurement systems. And we are happy to help PLN in doing that. So we wish you all the best on this digital journey. So thank you very much for your time and for giving us the opportunity to explain Nippon Toy's status in this activity. Thank you so much.
Okay, thank you, Mr. Thank you, Mr. Oke, Bapak dan Ibu sekalian, saya kira untuk diskusi hari ini terkait dengan knowledge sharing cukup sampai di sini. Untuk informasi saja, nanti bagi teman-teman di PLN Pusat, kita ada program untuk studi banding ke PTWK yang akan dilaksanakan di hari Kamis terkait dengan implementasi BIM ini juga. Jadi masih banyak program yang akan kita laksanakan. Bagaimana kita bisa mengimplementasikan BIM ini di proyek-proyek PLN, dan seperti tadi disampaikan Mr. Nick dan Mr. Kel, kita bisa mendapatkan advantage benefit yang paling besar dari sebuah proyek dengan implementasi BIM. Mohon maaf apabila ada salah kata. Saya memandu diskusi hari ini. Saya akhiri. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Selamat sore, good afternoon. Thank you very much, Mr. Nick, Mr. Kel.
Thank you.